Hello, I'm Susan Nash, and I'm really happy to be here today to introduce you to Junxuan Fan. And he's here to tell us a little bit about the OneStratigraphy project as a part of the Deep Time Digital Earth Stratigraphy Working Group. Welcome.
Yeah, hello. My name is Junxuan Fan, and I come from the Nanjing University of China. And also, I'm a member of the Stratigraphy Working Group of the Deep Time Digital Earth project. So today, I will introduce about a new stratigraphic database. And so the project goal of the Stratigraphy Working Group is to harmonize global stratigraphic data. So from this picture, we know that those existed stratigraphic database are only about 20% of the whole data. So they are about 80% of the data, they are invisible or hidden somewhere. So the most important job is how to find those data, make them available to the public, and share them. So one of the goal of the Stratigraphic Working Group is to establish a portal for the digitization and the sharing of the stratigraphic data. So we design the platform OneStratigraphy. So the idea comes from how we want to have a one correlation chart for the whole world. For example, through one correlation chart, we can see the correlation of any sections we find. So that's why we call it OneStratigraphy. So here shows the homepage of the platform. So it's totally free. Everyone can register an account and access to most of the data. So I should say that all the published sections are open to the public. So everyone will be able to use them. So here shows the example of the digitization of the stratigraphic legacy data. So from the right, you can see the technical report from the British Geological Survey. So they have been stored there for many decades. And if you want to access them, you need to go to the library physically. Otherwise, you can't find those technical reports. They are very important and has been gathered by British Geological Survey for half century. And so through the digitization work of the team, we can make them available online in a digital form and put them in the OneStratigraphy database. So everyone will be able to access them, use them, and share them. So this is an example what we are doing now. And we spent 2 years to increase the data volume of the OneStratigraphy. So here you can see the about nearly 400,000 data records we have digitized during the past 2 years. So there is a global geographic coverage because the DDE is an international science program. So all the data collecting effort should be based on the global data. And also from the right, you can see the increasing of the section records and also the fossil records. So we can see that at the end of this year, we will have over 10,000 sections and over 500,000 fossil occurrences. And it provides a very strong basis for the data sharing with other databases like PVDB, like Leptune. And also we try to establish the data sharing mechanism with other existing databases. For example, this maps showing the integration of the database of the data from OneStratigraphy and also Leptune. So we know Leptune is a very famous database for microfossils for the IODP project. So you can see that the integration of the two databases cover the whole world. One for the OneStratigraphy from the present land, and the Leptune come from the present ocean. And also in the past 2 years, we try to work with the AI team and the computer scientists to do some new analysis based on the big data. So here shows one example. we work with a computer scientist from the AI school, and we design a high performance computing program, the Kanap saga. And here shows the program, the interface we allocated on the supercomputer Tianhe 2. And the Tianhe supercomputer has been #1 in 2013 to 2016. So we just create an account over there and put our program on the supercomputer so we can see the calculating. And here, for example, each dot here represents one CPU core, and we can see the result from each of them. And if necessary, we can stop the calculating and restart the calculating if the result is not looks not very good at present. And also here shows one paper we published last year. So it's based on the big data from the OneStratigraphy and the AI algorithm we designed, and also the supercomputer Tianhe 2. And we can make some innovative study on the biodiversity curve. So this shows a very good example how to link the geoscience and the computer science. So here shows our curve for the paleozoic. And so we can see that the previous study by Roy in 2008 in Science. So we can see the erosion, the temporary erosion of the new curve, much finer than the previous one. So it shows the power of the linking geoscience and the computer science. So in the future, we will deeply collaborate with other AI teams from the world. We know that the AI technology can be used in data collecting, in storage and management of the data and the data platform, and also the data analysis and the visualization. So we hope that in the coming 1 or 2 years, we will make some important output and show it to the public. So that's my talk. Thank you very much.
Well, thank you. This is very impressive. I have a few questions. So the first one is that you mentioned that there are a number of geological surveys that are participating in this endeavor. Now, if a new geological survey would like to participate, would they have access to all the data if they share their data?
Yes, we provide the opportunity that all the international organization or geological surveys, they can join the DDE project. And also we welcome them to use the data inside the system or contribute their own data into the system.
That's nice. And then also with the biodiversity study that you did and the sort of paleoecology using big data and analytics, is it possible for people who have their own data set to join with you and collaborate on something like that to increase the biodiversity and, for example, understanding, say, mini extinctions?
Yeah, it's absolutely welcome. So we hope that all the scientists, they can join us and use our data or contribute their own data inside the system or collaborate with other scientists inside the program. So one of the major goals is that we want to provide a platform for international collaboration, and also for not just for example, people from paleontology. We also want to establish a bridge to linking different disciplines of geoscience, and even people from geoscience and the computer science and the data science. So this is one of the major goals of the DDE program.
It seems really valuable. And so, as you mentioned, it's not just for paleontology. You could use it for any kind of stratigraphy and stratigraphic application, whether it be for resource investigation or heat flows, anything.
Yeah, for example, we know that it was quite hard for our geoscientists or paleontologists to find someone to work with us, to find some computer scientists to work with us. But now we make it available because we have this big science program. So there are many data scientists and the computer scientists getting involved. So we can talk inside the program. For example, here shows some example what I want to do, and you can come and you can show what you can do, and then you will find the opportunity to work together.
I love that. That's wonderful. Well, thank you very much. I really appreciate it. And if someone would like to get in touch with you, do you have a screen that would show your contact information? Perfect.
Yes. So anyway, if they want to work with us or join us, they can just simply contact me. So here shows my email address.
Well, thank you very much. So I want to express our appreciation and hope that a lot of people contact you.
Yeah, thank you very much.